Today, the latest weapons, coupled with the fighting skill of the American soldier, stand ready, on the alert all over the world to defend this country, you, the American people, against aggression. This is The Big Picture, an official television report to the nation from the United States Army. Now, to show you part of the big picture, here is Sergeant Stuart Queen.
The English poet Ford Madox Ford once asked a question which has plagued military men since the dawn of history. He wrote, "Sometimes wind and sometimes rain. Then the sun comes back again. Sometimes rain and sometimes snow. Goodness, how we'd like to know why the weather alters so." The Army's need to know more and more about weather that surrounds this planet is a vital part of the expanded research program of atomic weapons. We all talk about the weather. The Army is doing something about the weather.
In war, the weather is either a friend or an enemy. It is never neutral. When it is bad, it is very, very bad. Freezing fingers, noses, toes. The many American men who fought through the winter campaigns in Europe or trudged back from the Chosin Reservoir in Korea will testify to that. Sometimes it lasts for weeks, sometimes for months. There are hurricanes that can toss a powerful ship around like a cork. Thunderstorms that raise havoc with a plane in flight. Innocent-looking clouds that conceal the lurking enemy. Sudden storms that transform peaceful tropical islands into scenes of death and destruction. In Korea, American forces went through practically every variation of weather conditions. From rain to snow, from 20 below zero cold to semi-tropical heat, from calm to typhoon, from sunshine to overcast. The Nazis were master weather forecasters. They knew about the weather and made the most of it. They knew it seldom rained during September in Poland. It took the Nazis exactly 16 days to crush Poland that dry September in 1939. But today, World War II armies like this are obsolete. The modern American Army, with its reliance on atomic weapons, rockets, and guided missiles, requires more weather information than World War II forecasters ever dreamt of providing. To gather that information, the Evans Signal Laboratory near Asbury Park, New Jersey, has been made the scene of a weather research program. Behind barbed wire, protected by maximum security precautions, the Evans Lab, which is a subdivision of the U.S. Army Signal Engineering Laboratories in Fort Monmouth, New Jersey, is the site of many scientific projects. Of 500 scientists working here, many are in the meteorology department. One of the Army's largest research centers, the Evans Lab, provides the multi-million-dollar plant, the elaborate equipment, which is required for the meteorology program. Side by side, in radar, radio, thermionics, and communications, scientific teams are working in support of the Army. Because the weather is big, it frequently requires big equipment. The international competition for knowledge, the necessity to know what makes Mother Nature tick, has made towers like this one an essential as man peers farther and farther into the world that rises above and beyond him. The Army has brought together a top-flight group of meteorologists. Their task is twofold: to design and develop new weather equipment, and to learn when, where, why, and how the weather works. This is the story of these men and the knowledge they have wrung from the sky around us. It is in the aerograph and sonde section of the meteorology department that much new equipment is designed, developed, and tested. Equipment used to explore weather conditions 20 miles above the surface of the Earth. It takes long hours and constant experimentation to find practical ways of exploring the upper atmosphere, where the temperature may be 120 degrees below zero, the humidity almost unnoticeable, and the air pressure 1/100th of that on Earth. But equipment to do exactly that has been developed. This young lady, who is a mechanical engineer, is checking a circuit from one of these new sensing devices, a device designed to be sent up by plane or balloon to 100,000 feet. Called the Radiosonde, it is a remarkable achievement. This is how it works. The senses of the Radiosonde, the eyes, ears, nose, taste, and touch, which feel out high-altitude weather conditions, are called elements. Incredibly sensitive, this tiny, delicate instrument, which you see pointed out by the pencil, is a temperature element. It reacts to minute changes of heat. An engineering wonder, it is made of a carefully prepared ceramic material covered by a protective shielding less than 1/1000th of an inch thick. It will record temperatures down to 120 degrees below zero Fahrenheit. The humidity element, which is a little larger, has a thin film-like layer which responds to moisture in the atmosphere. In just a moment, you'll see a demonstration of exactly how sensitive these elements are. Here, a temperature element is removed from its protective vial and connected to a special strip chart recorder. The heat of the scientist's thumb and forefinger is instantly recorded on the strip chart. Although it took many months of experimentation and thousands of dollars worth of elaborate machinery and equipment to produce this tiny element, it can now be manufactured for less than 75 cents. As the temperature element detects fractional changes of heat, so the humidity element discerns minute fluctuations of water content in the air. For this test, a few drops of water are used to moisten the corner of an ordinary desk blotter. Although the blotter absorbs the liquid, the humidity element easily picks up the mild evaporation which takes place. And the strip chart notes the results. When these temperature and humidity elements, together with a small barometer, are mounted with a miniature lightweight radio, we have the Radiosonde. This ingenious device is used to gather information about the weather thousands of feet above the ground and to radio it back to the meteorologists waiting below. It is the best instrument of its kind in the world. The Radiosonde, which means radio sounder, weighs only 2 pounds. yet its ultra-high frequency signal carries over 200 miles. This is the radio section, the transmitting tube, the antenna. Although winner of first place at an international convention in 1956, it is already being replaced by a newer, more advanced model, seen here on the right. The new sonde is now in the engineering stage of development. But let's look at some of the equipment other nations are using. This is the British sonde. Relatively heavy, it is less accurate, and is more complicated than ours. The sonde from Finland, while the lightest made and inexpensive, is less accurate. The Polish sonde, only reasonably accurate, is complicated, difficult to operate, and relatively expensive. The Japanese sonde, while quite accurate, is handmade and very delicate. The sonde of the Soviet Union offers an interesting comparison. While it is generally accurate, it is far less advanced in technique than ours. Many of its parts are mechanical, where the American sondes are electronic, and its tubes are of an old standard design. Extremely accurate, easy to manufacture, and costing less than $20, the American sonde is a fine example of the Army's determination to provide the meteorological information needed by artillery, missile, and atomic warfare teams. Last but not least in importance in the radiosonde system is the ground equipment, which receives the radio signal from the sonde's miniature transmitting set. This is the data recording and processing equipment, a linked series of electronic brains. These machines automatically record temperature, humidity, air pressure, and wind data, process it, and provide information upon which a weather trend may be determined instantaneously. For many months in the aerograph and sonde section, different phases of the radiosonde system have been undergoing tests. A series of balloon flights has been conducted. Before each flight, however, every part of the sonde must be checked out to see that it is in perfect working order. A pressure chamber, which simulates high altitude conditions, is used to test the instrumentation of the sonde. The unit's power supply, an 80-cell battery, is always activated at the last minute. The battery is designed to last for 3 hours and is energized by adding water. At the same time, the balloon, which will carry the sonde up to over 100,000 feet, must be treated in hot water to help it expand when it reaches the thinner atmosphere far above the Earth. And the battery, of course, must be tested too. This entire system, as you can see, is designed for use in the field under combat conditions. In operation, the radiosonde will provide vitally needed weather information quickly, efficiently, and accurately to Army ground units. Every part of this amazing device was developed here at the Evans Lab. The elements, the radio, the battery, and the highly accurate ground equipment. While outdoors, the weather balloon is prepared for flight, the sonde is placed in a ground check chamber, which ties in the transmitting set with the ground receiving equipment, which is already standing by. Even the balloons used to carry the sonde are subject to experimentation. This is a new trial balloon made of synthetic rubber. For the higher that the sonde is carried, the more information it will send back, and information is what these men are after. Although the lab already holds the world record for a free balloon flight, 142,000 feet, work on these hydrogen-filled bags does not stop. When the balloon is fully inflated, a small parachute made of orange waterproof paper is attached. Many of the sondes, returned safely to Earth, are found and used again. A 50-foot length of cord is used to suspend the sonde well below the gas-filled bag. When these final preparations have been completed, the signal light for launching is given from the control room. And here she goes. Tracking equipment is quickly put into operation as the balloon rises, and the recording and processing apparatus begins to transcribe the weather above. The American sonde is highly regarded throughout the world and is often used as a standard because of the proven superiority of this electronic equipment. A steady stream of weather data is sent down by the sonde to the men waiting below. As the information comes out of the processor, a trained technician notes the machine's calculations and compiles the results of the test flight. When all of the results are in hand, the information is taken to the laboratory weather station. Although the primary purpose of such balloon flights is to test new equipment, the weather data gathered is of value to other laboratory scientists who frequently need to know the local weather picture. The compiling of weather information from many widely scattered individual weather stations is the technique used by most forecasting systems. From many separate reports, a total picture is derived. Today, a revolutionary system of local weather forecasting is being perfected by the scientists at the Evans Lab. For the first time, with this radar weather set, a single glance at the special tracking scopes will reveal the weather picture for 200 miles. The operator of the radar weather set can tell the intensity, the height, the range, and the direction of any storm within that 200-mile area. This special stop-action film speeds up the work of the radar set. Taken during a spell of extremely bad weather, here you see a high-altitude storm moving from Buffalo on Lake Erie past the Evans Lab and out to sea. Heavy rain and snow descended from the same direction and blanketed the area from New Haven to Philadelphia. Despite all of the electronic equipment available for research purposes, the basic work must still be done by the human brain. For many of the scientists, thinking is the main job, for no electronic brain can invent new ways of solving a problem. It takes long years of training and study to make an expert meteorologist. With geophysicists like this, today's blackboard theories become tomorrow's tools for weather research. Here's one of the most unusual studies currently being made. This oversized fishbowl filled with water is called the tornado tank. By creating currents in the water, it is possible to duplicate exactly the action of a tornado. Those little black globules are pieces of soluble dye which will show the action inside the tank. You are about to see a miniature tornado. It begins with a slowly circulating ground current. When a persistent updraft is added at just the right moment, the circulating current will begin to wrap itself around the updraft, forming the so familiar twister. The result is devastating. Real houses in the heart of a real whirlwind would be tossed about exactly as these are here. For the power of a tornado is equivalent to an atom bomb being exploded every second. Through this study, the Army hopes to develop a better understanding of tornadoes and a new early warning system. Another series of experiments is being conducted with rockets. Aerobee rockets like this one have been used to collect air samples from 80 miles up. Other rockets are used to map the winds on the borderlines of outer space. This rocket is designed to spray forth 10 packets of high explosives during its ascent. By measuring the time lag between the preset explosions, scientists on the ground below can compute wind and temperature data at the top of the world. The packets of grenades are carried in these compartments and ejected out the front of the rocket. A special radio transmitter sends back the sound of the bursting grenades to tape recording equipment on the ground below. These films were taken at an actual test firing of a grenade-spraying Aerobee rocket. This experiment, performed at the Army Proving Grounds at White Sands, New Mexico, was conducted under the technical supervision of scientists from the Evans Laboratory. Elaborate electronic equipment was set up to trace the flight of the rocket, which would reach 80 miles above the Earth's surface. Tracking and sound ranging equipment would record the information beamed back by the transmitter inside the rocket. Weather research, helping man climb toward the stars. In just a moment, you will hear an actual tape recording of the signals sent back by this grenade-firing rocket. Men stand by as blast-off time approaches. Listen now to this tape from the White Sands Proving Grounds. 8, 7, 6, 5, 4, 3, 2, 1. Fire! Those pops you hear are the grenades exploding. From this recording, physicists are discovering new and invaluable knowledge about the weather on the borderlines of space. The firing is over, but the work of these men to determine all the results has only just begun. Many other experiments are being conducted at the Evans Lab. Some of these small instruments were built for Operation Vanguard, the Earth-Moon satellite. An important job for the satellite was the assignment to develop a solar battery, a battery which could take the power of the sun and transform it into electricity on which to run the satellite's scientific equipment and its radio set. These cells, taped here on a drum which revolves under an artificial sun, constitute the new solar battery. Placed as they will be in the satellite itself, they generate a steady 12 volts. When the Earth-Moon satellite is launched, man will have taken one more step into the wonder that lies beyond his own planet. Of course, what you have seen in this short film is not the whole story. There are many other projects being carried out at the Evans Lab. Not the least of these is the calibration of Army reference barometers before they are used to check Army field barometers. The sensitive, delicate barometers are put through a series of checks in this specially constructed constant temperature chamber. And in addition, there are many projects for the Air Force and the Navy as well. From all this, from these scientists and their work, is coming new knowledge. Knowledge which will serve not only the Army, but which one day will be of value to all mankind.
The men and women of research programs like the one you have just seen are too frequently forgotten. When you see a military parade or a newscast about a new Army weapon, remember the scientists behind the scenes. They deserve your thanks. This is Sergeant Stuart Queen, inviting you to be with us again next week for another look at your Army in action on The Big Picture.
The Big Picture is a weekly television report to the nation on the activities of the Army at home and overseas. Produced by the Army Pictorial Center. Presented by the United States Army in cooperation with this station.